Now, if you click on any of these tiles, it takes you to kind of a data store-wide view of performance over time. So it tells you, for example, how many IOPS, both in terms of reads and writes, the system serviced. And you could also look at latency, flash percentage, so on. And if you click on any of these data points, say there was a peak in performance right here, and you're wondering, well, what VMs were using the IOPS at that point. You could click there, and it tells you what VM was generating most of the IOPS. And if you look on the right side, you get a sorted list of VMs by IOPS consumption. So you know exactly which VM is creating those peaks in throughput or latency. Now, if we go to the per VM view, you see this. You can see this information all on a per VM basis. So let me just hide this right now. And you see that the names you see here are not the names of LUNs or volumes or hexadecimal digits, anything like that. They're actually the names that you would see if you went to vCenter. So you know immediately what storage object corresponds to the VM that you're interested in.
So how are you picking those out?
Yes, we get that by using the vCenter APIs. We get all of that information, and then we correlate it with all of the per VM information we've collected on the file system side.
Right. So it's look up the guests.
Yes.
Match the file names to what you see on disk.
Yes, exactly. And you can also sort by any of these columns. So a very useful thing to sort by is the latency, because that gives you a very quick view of what VMs have performance problems on the system. Right.
32 milliseconds.
Yeah. Oh, yeah. And this is a demonstration system, so we purposely created some VMs with performance problems. And if you mouse over them, it gives you a breakdown of where that latency is being spent. So you see that of this 32 milliseconds, 31 milliseconds is actually being spent in the hypervisor. So this hypervisor is very heavily loaded. And if you...
So where are you collecting that data from? VMware's?
Yes, we also get that from...
Hypervisor?
Yes, we get them from the real-time counters on VMware, which are always active. So and then we...
So this isn't your response time. This is host C latency.
This is what the guest OS sees.
End-to-end latency.
That's nice. It really is nice. Yeah.
Yes. Name something else that has
end-to-end
latency. Quick.
This is what the application is actually seeing.
I have tools, but they're all...
Yeah.
I have tools, but they're all at the guest, not at the storage system.
Right.
Wow.
Yeah, and you could also see that looking at the graph.
Yeah, you know why I bought one.
Can I change this 60 watt out for 100?
No, those are illegal now.
And look, yeah, and by looking at the graph, you can also see its performance over time. So if a user says, it comes to you and complains, well, my VM for some reason is always slow after lunch, you could basically look at the latency breakdown after noon every day and see where that VM was incurring those latencies. And we also have a little bit of host side stats.
The guy's playing games, and that's why.
Yeah. Or downloading something. And so in this case, it's the host was the bottleneck. So let's click on the host link. We have a few vCenter stats that we also provide here, just so that you could do an additional level of drill down. And you see that in this case, percent swap weight is quite high. It's at like 20%. So the reason this VM is slow is because the hypervisor is swapping it. Right? And we also have percent CPU ready. So if percent CPU ready is high, it means that the VM is ready to run, but the hypervisor is not giving it the CPU it needs. So at a quick glance, you know immediately, do I need to give that VM more CPU or more memory? Right. Now the next VM here has a different problem. You see it has a long yellow bar instead of a green bar. And if you mouse over it, we find that, here, let me switch to the latency graph again. If we mouse over it, we find that most of that 12 milliseconds is in the network. 11.2 milliseconds is the network. So,
what, you got 100 megabit Ethernet? 100?
Yeah, I purposely throttled the network for this VM.
Yeah, of course.
And then on the next one has a slightly different problem. You see it's actually going to hard disk. The hard disk is contributing 1.6 milliseconds on average, and you see its flash hit percent is less than 100%. Right? So it's a few clicks. You can immediately tell, do I need to contact my VM admin, my network admin, or my storage admin? So you basically can triage, probably over 90% of the common performance problems with a few clicks and in about 10 or 15 seconds.
Is there such a thing as a storage admin in this kind of environment with a Tintri?
Right. It depends what the storage admin does.
You're in a room full of storage guys.
Right. Right.
So what you just said.
They're all worried about their phony baloney jobs.
Thank you for the warning. Yes, if you are one of the top smart storage admins, you will have
There's none of
plenty
them
of work.
here.
If your main job is to carve up LUNs and provide, data stores for VM admins, then you'll have less work to do.
What's
But-
the
but more
what's the
than Twitter.
reserve? What's
Haven't
the
seen that
reserves
before.
column here?
Excuse me?
What's the reserves column?
The reserves column? Okay, that tells you, remember the reserves gas gauge? That basically gives you a high level view of what percentage of overall system resources the VM is using. So the reserves basically tells you what
Can we see
fraction
it?
of the box's performance resources that VM is using. So
Can
this
you see the
VM,
reserves column?
But there was a couple of those that were like 100%.
at the reserves percent column,
But why would 26% of the box not equal a higher IOPS?
oh, that's because performance resources also include flash capacity. So this VM is getting a large flash
Right, it's a 1
miss
terabyte.
rate. So it's
Yeah.
using a lot more flash than the other VMs. So we use
So that's the percentage of performance of the Tintri system that is being consumed by that particular VM?
That's correct. And when we say overall performance, you have to consider that there are many resources that can be a bottleneck in the system, right? It can be flash capacity, it can be network bandwidth, it can be CPU utilization, it can be any number of things. So what we do is we take all of those metrics and we apply a market scoring rule, which basically prices the resources based on relative scarcity, and it comes up with a single price for running that VM on the system.
So that column should roughly sum up to 100% someday.
Yes, exactly. If you're using the full capacity of the system, then it shoots up to 100%. So now I'd like to move to a different phase of the demo. Basically, I'm going to now demonstrate the upcoming product, the 1.4 release of the product, which will be available shortly, basically in a matter of a couple months or something, 2 to 3 months. And so this is now a different system which is running the new code base. And the new features in this release, the most notable ones are advanced snapshot and cloning. So with this release, you can create instantaneous clones, like hundreds of clones of a VM without using any additional capacity. It's only as the VMs are actually used and changed that they consume additional capacity on the system, right? So this release also has scheduled snapshots. We had snapshots before, but they could not be scheduled on a regular basis. So let's go to the virtual machines tab again. And let's pick a virtual machine here. I'll pick this one, Demo 6 template. If I right-click on it, you get a few new options under snapshots. Basically, you could schedule regular snapshots. By default, you could schedule a schedule for the whole system, which would apply to all VMs in the system. But you can also override the snapshot schedule on a per VM basis. So for example, instead of using the system default schedule, say I want to do it at 2:30 a.m. every day, and then later I decide, oh, I don't want to do it every day, I'll just do it every weekday, I'll skip the weekends, and maybe instead of 2 days seems a little short, so I'm going to change that to 2 weeks, so forth. Right.
So snapshots are read-only and clones are read-write?
Yes, that's correct.
And VM consistent snapshots use VMware tools as the VSS agent?
Yes, that's correct. VM consistent tools basically make all of the VSS callbacks. So if you have the right application with the right callback, you will basically get an application consistent snapshot. And so when you schedule these snapshots, you can pick crash consistent or VM consistent.
Is there a scripting interface for Linux and other non-VSS?
We currently do not have a scripting API, but that is on our roadmap, and we hope to have it soon. Now, the other really exciting feature, however, is the cloning feature, because once you have snapshots, you can clone these snapshots. You could also clone just the current state of the system, in which case it will immediately create a snapshot. Right, so in this case, let me pick this snapshot here, which I called Gold Master. It's a master. You could imagine that it's a special master snapshot that you created at some point. And I'll give it a base VM name that's more interesting. So just could give it Yeah, there we go. So T1, way down. And then I'll pick some number of VMs. You could create up to 500 at once, but the slowest part of creating the VMs is actually adding them to vCenter. So I'll just stay with something like 25 for now. Also, if you have VMware customization specifications defined on vCenter, then you could pick one of those specifications to be customizations to be applied as the when you create the clones as well.
Can you go the other way and offload from vCenter?
Yes, absolutely, and that's a very good question. And we now support also with this release NFS VAAI or VAAI for NFS. So when you do clones from vCenter, it will use the VAAI acceleration and will use the advanced cloning feature on Tintri. And I will demonstrate that as well. So you'll see the difference. So I'm going to pick 25 VMs. I'm going to hit the clone button. Now I'm going to quickly switch over to vCenter so we can see the clones being created and added. Go to the bottom of here. And you see those clones that we just created, SFT1, you see 25 clones of those, right? And basically I'm going to select a handful of these clones that I just created and power them on. Okay, you see they're turning green, they're coming up. I'm going to open a console so we can see them boot.
So now you guys currently dedupe the flash but not the spinning disk,
That's
right?
correct. That's correct.
So you just created all of these clones. In the flash, because it's deduped, that's essentially doing nothing.
Also, by the clones actually dedupe the hard disk as well, so they don't actually use any hard disk space either.
Are they deduped or are they single instanced?
They're single instance.
The clones share metadata, so they share any disk that has not yet changed.
Right. Yeah, single instance.
Yeah.
Okay. And
so
then as soon as I actually do something on a clone, it's going to start inflating.
Yes.
Yeah. So I think it took about 7 seconds
but
to.
it doesn't do a full inflation all at once.
No.
Oh, so you're partially deduping the disk.
Yeah.
Yes, exactly.
With clones.
It's actually probably the majority of the dedupe you
versus
might see in most systems as a result of cloning.
If you
clone.
build it from a greenfield, yeah.
Yes. And so it took about 7 seconds to boot. That's actually a lot faster than my desktop boots because obviously this is booting completely from flash. And so when
You haven't gone in the back and stolen an SSD for your desktop?
no, I'm still using a hard disk actually on my desktop. And that's one of the things people notice though is a lot of the developers at Tintri are now using virtual machines to do all of their builds and development. And they notice that it's a lot snappier than their actual desktop. And
because even though you're NAS, using it as conventional NAS is a good idea.
right. And so I'm just going to log in here, and I'm going to launch a web browser. And basically, you see it's accessing an external site on networking. Everything is configured. And basically, I just created 25 VMs just like this one, just as easy to power on, right? And just a few days ago, I did 200 of them. It took about a minute. And the slowest part was just adding them to vCenter. So now what I'm going to do is do the cloning, but except from vCenter using the VAAI plugin. Yeah, I hope in the future VMware will come up with easier to pronounce acronyms.
Yes.
Good luck with that.
As do we all.
Maybe they'll come up with acronyms that somebody else hasn't already taken.
Right. Okay. That would be. And of course, something with more consistent capitalization conventions.
That's the problem, isn't it, though? All the good ones have been taken.
Yes. Certainly all the 3-letter file system names are taken.
So why couldn't somebody like NetApp retrofit the ability to get that information out of the API into their product and do something similar to this?
Right. Well, given enough time, effort, and they certainly have a lot of smart people, they can do this. But just consider how long it takes them to integrate other technologies like exactly.
Well, I use NetApp as an example because they're obviously the most obvious.
Right. But I mean, other companies can do that as well. And you could ask a similar question: why couldn't people have added dedupe or whatever, and also do similar type of things? They can, but once you've built the core file system, it's very hard to retrofit it with a new core technology. You can do it, but it doesn't work as well.
Especially if you don't want to piss off the people who like it the way it is.
Yes, exactly.
But, if you go, I'm going to do this, and that makes it different, then you're annoying some of your existing customers. And it's kind of like, why does HP still sell EVAs? Because people still want to buy them.
That doesn't mean that's right, though, to buy EVA.
No, but it does mean it's right for HP to sell them as a business decision.
Yes.
You know, for thee and me, as soon as they had a 3-par, buying an EVA from them wasn't a good idea. But for the guys who like EVAs, they are.
So here now I'm going to select the same template for cloning purposes.
I'm sure that
He is.
Yes, he is.
Yes, he
Yes,
is. Not watching
Twitter.
right now.
Sorry, Calvin.
But this time I'm selecting the cloning option from the vCenter GUI rather than the Tintri GUI. And first I'm going to clone this without the VAAI acceleration. So I'll call this demo 6 no VAAI. I'm actually going to clone it to a data store without VAAI. And this is not a large VM, it's maybe 30, 40 gigabytes. And I'm just going to pick this data store here, which doesn't have VAAI. And I'm going to click Finish. And you see, if you look on the bottom here, you see that it's starting to clone. It goes up to about 10% pretty quickly, but thereafter it kind of slows down. If I were to let it run to completion, it would take about 10 to 20 minutes to complete this clone. And it's only like a 30, 40 gigabyte clone. Now I'm going to clone the same VM, except this time with VAAI. And also, as part of VAAI for NFS, you have the option of doing space reservation. So you could pick a thick provision format if you like. So I'm going to pick thick provisions lazy zeroed as the format. And I'm going to pick our Tintri data store, which has VAAI acceleration. Okay. Now you have to watch carefully because this is going to go pretty fast. Look at the bottom. So there we go. Wow. So about 2.5 seconds. And it's going to take that long regardless of the size of the VM. It could be a terabyte VM and it will take 3 seconds, right? 2.5. Yeah. So that's basically the demonstration.
Yeah. Hey Ed, in the UI, can you show them the per vdisk stuff back in our UI?
Okay, certainly.
Just 2 seconds on that.
A couple of minutes if anybody wants to see anything else. Question.
Yeah. So we were looking at per VM stats here, but you could actually go one level further. You could click on vdisk, and it will list all of the individual vdisks that are a part of the VM as well, and you get per vdisk stats. So you can tell immediately whether a virtual machine is swapping, for example, whether it's being swapped. So the same kind of information, but available on a per vdisk basis.
So you can
Same
sort them
latency
by,
as well.
You can sort them by latency. For
And you can sort them by latency.
Could you talk about pinning as well?
Oh, okay. I mentioned
Talk about what?
Huh? Pinning. So I mentioned earlier that we also have quality of service mechanisms that you could implement on a per VM, or in some cases per vdisk basis. And today the main mechanism we have is something called pinning. So if you, for example, find that there's a VM with flash miss ratios, mainly because it's a cyclical VM, it runs maybe once a week or something, so it gets kicked out of flash, but when it runs, it's very important and you want it to be always served from flash, you could select this pin option. So if I could click pin, you see a little pin icon appears next to the vdisk, and that means that vdisk will now never be evicted from flash. So you can guarantee that it's always going to be serviced from flash. And you could do this on a per vdisk basis so that if you have a database VM, you could just pin the index vdisk and not the log vdisk, for example.
I want the opposite too.
Yeah. So if you want to be absolutely sure,
the data warehouse load runs at night. If it's got 12 hours, if it takes 8, I don't want the flash consumed by it.
Can you schedule pinning?
Can you?
no, you cannot schedule pinning.
Can you force something never to be in Flash?
That we don't have yet, but we are thinking of adding options in the future to give it both more or less
I
resources.
think the other thing you guys are asking about is really handled gracefully by the working set analyzer. It's the piece that really looks at the access patterns of these 8K blocks and figures out, based on that, relative to everything else that's happening, where does it really belong? So, you know, in the data warehouse example or in the file, you know, big file server example, some of the data won't be accessed often. It will be moved over to spinning media. The rest of it stays maybe compressed in Flash. So sort of the algorithms are already intelligent enough. This is more if you know you just have that super tier 1 app you can never have out of Flash. You can pin